Okay, this is the first video on test measurement validity and reliability. Let me explain. This part of the class just kind of really takes on a completely different dynamic, a completely different nature. The purpose of this is to get you to think more about test and measurement, but it's not maybe not the focus that you would expect, because most of us who teach mathematics, when we think of tests, we think about tests that we give to our students. I do hope by the time we complete this component that you will think more critically and take the time to more closely examine the tests that you give to your students, and take time to more closely examine the test results that you get from those tests. But that's not the sole purpose. The sole purpose here in these videos, these upcoming videos on test and measurement theory, is to get you to think more in terms of how measurements are collected, how instruments are created that are used in education research, to make it very pertinent to your life. Those of you who wish to complete the entire program, you know that there's a research component, and you're going to be required to in a group setting to come up with a research topic and carry it out, and that actually serves as your master's thesis. So even though I hope this brings awareness to the test that you give to your students and the interpretation of those results, that's not the sole purpose. The sole purpose, or at least the main purpose here, is to get you to think more about testing, measurement theory, validity, and reliability when it comes to the instruments that you use in education research. Currently, I'm serving on a doctoral committee. A lady who is a professor at Shawnee State is working on her PhD, and one of the things that's driving her the craziest in putting her proposal together are the validity and reliability issues that the dissertation guide requires her to examine and report. So, guys, this stuff is gonna hit you. It's gonna hit you smack dab between the eyes once you start thinking about where you're going to be headed with the master's thesis. Just to get your attention a little bit, I pulled up a study. There's obviously a lot of focus on ACT scores these days, but this particular study sought to examine predictive validity of ACT exam scores. And I chose this because I know a little bit about these guys. Bittinger, I'm pretty sure, is still at University of Chicago. Brent Evans is a professor at Stanford. And Devin Pope, I'm not really sure, but I think he was a student at Stanford of Brent Evans back when this was actually published. He may have actually completed his PhD by now, but I'm not for sure. But anyway, the scope of their study was to, again, examine the predictive validity of ACT scores. And what they actually found, which is really kind of irrelevant but kind of cool nonetheless, is they found of the four components of the English, the mathematics, the science, and the reading components, that only two were really that predictive of positive college outcomes. And that was the English score and the mathematics score. The other two sub-tests, the reading and science, provided little, well, I can read this, provided little or no additional predictive power. Now, I kind of hope that, with me giving you this source, that you can look this up and you'll actually read this. And if you actually do read even their abstract, but especially if you get into their document and try to read it, you'll see that to really understand what they've done, you're going to have some background in test theory. You're going to have to understand what's validity and what's reliability, and how do all these different measurements that they've collected and reported, how those come together to tell the story that they're actually telling. So I hope you'll follow through. I don't know. You will or you won't. That's for sure. Guys, more pertinent, I guess, to your situation is to examine what's currently going on for the cohort that is set to graduate soon. And let's think through what they're doing. Now, I'll tell you, their understanding of measurement and test is going to be held to a lower level or a lower standard than our next cohort going through, because they didn't have the opportunity to take this class until some of this stuff has been established. But nevertheless, they got some pretty cool research going on. One group is examining behavior and discipline reports and how they impact selection in algebra classes. I think it was eighth grade high school math courses. Another looks at a comparison of situational and dispositional data with academic achievement in predicting course success in developmental mathematics classes. And the dispositional data information that they're using comes from a student engagement survey. The third bullet down there, one group is examining achievement. Going to do some fancy schmancy stuff with final exam scores, breaking it into factors and reliability and validity analyses. But they're looking at a comparison of achievement in college-level statistics classes that have been offered either traditionally on campus or as part of the dual credit program in local high schools. Now, when I look at each of those, the thing that jumps out to me is measurement. All of those studies are collecting some type of measurement. And up to now, your focus has been, well, how would I statistically analyze the measurement? Those measurements. Would it be an ANOVA? Would it be an ACOVA? Would we do a multiple regression, logistic regression? But guys, there's an underlying feature there that we haven't discussed yet, and that is the appropriateness of the measurement of the instrument that's been used. Because guys, in research, we find out that some measurements are good and some measurements aren't so good. So guys, that kind of leads me into the opening statement. I quoted this, I think, from an introduction to research and education text. I think it was Jacobs and Walker. I'm not really sure. I use so many different ones. But information derived from test and measurement instruments ranges from excellent to useless. Guys, just because you create a measurement instrument and you go out and give it to people, it doesn't necessarily mean that the results can be used for anything other than maybe just a descriptive in a descriptive manner. So, so guys, anyway, quantitative research, which most of you will be doing in our program in mathematics education, which is for us geared toward improving instruction of programs, often depends on collecting and examining measurements. And we saw that the three that we're currently doing certainly rely on collecting certain measurements in education. All right, guys, let's get to the nuts and bolts of all this. The two important concepts that we need to learn and we need to study in examining the usefulness of scores are validity and reliability. Guys, validity to me is, does the test do what it's supposed to do? Is it actually examining what it claims to examine? So more appropriately, validity is the extent to which scores on a test enable one to make meaningful and appropriate interpretations. I'm maybe a little bit more old school because I studied validity and reliability back in the late 90s, like specifically 98, 99, 2000. Over the past 15 years, the definition of validity has changed really from is the test testing what it's supposed to test to the focus on the interpretations of the test results. Guys, reliability is much easier to define. When you think reliability, just think consistent. Are the scores consistent? And we come up with a lot of different ways in testing theory to determine the reliability of a testing instrument. So how reliable are the scores? Now, the main focus of this video, we're going to get into classical test score theory and measurement errors, systematic errors, We'll get into validity. Those are going to be the scope of the next 2, 3, probably, maybe even 4 videos. But the main focus of this video is to examine what we call reliability. And again, it's the degree to which the test produces stable and consistent results. We don't want an instrument that we're going to go out here and produce for results that we're going to go out and publish to the education community. We don't want that instrument to be, to produce inconsistent results. We want it to be stable and reliable. So a test is reliable, and these are 2 things that if you take notes, and I hope you will, because this is stuff we're going to have to look back at, and I don't think you want to look back at each and every video, because there's going to be quite a few of them. But there's 2 things the way I think about reliability. First of all, are the scores on each individual the same over repeated measures? So this brings in the time component. If I give a test on Monday and give it again on Friday, I want my test to be stable. I want my scores on that test to be consistent over time, over repeated measures. The other thing that we focus on is rank. Now this gives you more of a comparison of all the other people who are taking the test. The first bullet there focuses more on the stability, consistency of the individual scores, but the other component actually looks at the ranking component and how people compare to other people who have taken the test. So individuals will have the same or nearly the same rank on repeated administrations. Now diving into that just a little bit more. Now I'm going to get into error a little bit. I'm going to get into random error and systematic error a lot more in the next video. But guys, as you would expect, any measurement that we take, we expect variation. There's something we used to do in graduate school. One of my professors did this all the time. He would choose a person, supposedly at random, and he would have a measuring device, a meter stick or whatever it may be, and he would have the person stand up against the wall, and he would choose another student to come over and measure that person. He would measure their height down to, I think usually he tried to get it down to like 1/4 of an inch. Well, he would have the student go out and take a drink of water and come back in, and then he would choose another student to measure the height again. Every time, I've seen this happen, I don't know, 25 times, every time the height of the student changed. Well, he makes a joke of it that it must be some really powerful water, but the fact of the matter is, there's just differences in measurement from person to person. Now, the person's height didn't change, but the error of measurement actually changed. Now, that becomes something really cool once we get into classical test score theory, when we actually start talking about true scores and observed scores and errors, and there's a linear function that connects all these things. But guys, variation should be expected on each person. For example, when I think about IQ, I assume that I have a true IQ. But I have taken 9 IQ tests, and the only reason I got corralled into being part of a study at the University of Kentucky a few years ago is the only reason I've taken so many. And I'm not talking about these wacky things that you take on Facebook or Twitter or something like that. I'm talking about a real-life, sit-down, 3 to 4 hour test that's given by a certified IQ test giver. I've had 9 tests. I've never scored the same thing yet. My IQ, I don't think measures doesn't vary, but the error of the measurement varies from one person within one person. So if you think about that, if I have a true IQ, and let's say that my true IQ is 120, and I have one test result 122, the next one's 112, the next one's 130, then all of those measurement errors can be seen as a set of errors. And we could actually take the standard deviation of those for one person, which is actually where we get into the standard error of measurement on the particular person. Well, guys, that's not the way it works in statistics. That's certainly not the way it works in education research. because there are clearly problems and issues with repeated measures on one person. First of all, you get time issues. Second thing, you've got practice and fatigue will influence the scores. So the solution is we give the measurement to a large group of students, subjects, however you want to talk about this, on 2 occasions, and we use the paired measurements, specifically the correlation between the paired measures from person to person to estimate the spread for the average person. So we're going to get into different ways that we can examine this consistency using paired measures and internal consistency, which we'll talk a little bit about. All right? So guys, first of all, in measuring consistency, just to give you a summary of what we just talked about, we can examine the relative position over repeated measures of the test. Again, if our test is reliable, the rank shouldn't change from Monday to Friday. The person who scored the highest on Monday may not score the highest on Friday because we expect a little bit of variation, but we don't expect a lot of variation. We would expect them to still be one of the higher scoring people on Friday. So guys, in a nutshell, each person's rank stays relatively the same. The more shifting or the change in rank creates less consistency in rank, therefore it creates less reliability. So this whole reliability thing, you can day in, day out think about it as the consistency, both in terms of testing and retesting, but also there's going to be an internal consistency of the skills that we're actually trying to measure. So guys, over the next 15 minutes, I'm going to teach you far more than you ever cared to know about reliability coefficients. Reliability coefficients are these numbers that we spit out. They can be thought of as behaving a lot like correlation coefficients that give us an indication of the consistency of our measuring device. Well, guys, the first thing I want you to think about is something called a test-retest reliability. And what this does, it does just like the name says, it gives a test, and then sometime later it retests the same subjects, and it measures the consistency of the subject scores over time. We call this a coefficient of stability. So anytime you bring in a time component to reliability, we typically refer to that as a stability issue. So guys, a high coefficient of stability will permit generalization, and a high coefficient indicates that we have stability over time. So if we're trying to tap into some sort of construct like attitude toward mathematics, and we come up with this instrument that we want to use, well, we want that attitude, unless there's some external source that changes that, which is not the issue of reliability, we want the reliability, this instrument, to be consistent in measuring these attitudes of mathematics. Guys, this coefficient of stability is slightly flawed because it assumes there's no practice effect or memory effect. And guys, we should, a little bit of common sense kicks in, and we can clearly see that time between tests will have an impact on the practice and the memory effect. Guys, if we don't have enough time between the tests, then memory effect may inflate the reliability estimate. For example, if I give my first test on Monday and give it again on Tuesday, we've all been there. We remember problems that we worked the day before, so when we see that same problem on the next test, then we're not even going to work it out. We're going to remember, well, I got the answer of B26 yesterday, just circle B26 today and go on with it. Well, guys, that's going to give you a reliability estimate, because even if those questions are right or wrong, doesn't impact the reliability. It's looking at the reliability of the responses, not whether or not that they got it right or wrong. Another thing is if you wait too long, you get what we call differential learning, which may affect the reliability estimate. For example, if I wait maybe 6 months, then you've got to think of that 6 months as an opportunity that those students had to learn stuff. And we know back, if we can go all the way back to the era of Bloom, who showed early on that all students are probably, well, not all students, but most students are capable of learning the same material. It's just some students learn a lot quicker than others. So within that 6-month period, you could have a differential learning component that may kick in that would affect the reliability estimate. And actually, that would decrease the reliability of our measurement. Second thing we get run into are equivalent forms reliability. What you seek to do here is you seek to find what we call parallel forms or alternate forms. So version A, version B. And in the classroom, we come up with these all the time, and we just assume that they're the same thing. And I never will forget, back in graduate school, I got called out big time because I was talking about these two parallel tests that I gave. And on one version, I gave x, it's weird that I remember this, x squared minus x minus 6 is one question to test factoring, which would be x minus 3x plus 2. But on the other one, I gave x squared minus x minus 12, which was x minus 4, x minus 3. Well, my argument is those two questions would be identical in assessing factoring. Well, I got called out big time on that one, and later on, after I studied this enough, I realized why that's not true. So anyway, these equivalent forms kind of dive in or use that phenomena of creating very, very, very similar questions, but nevertheless they're different in terms of the items. So, guys, the beauty of this is they're administered at virtually the same time. They're administered to the same subjects, and they address recall and/or practice effects for things that are given over time. So, guys, we call this a coefficient of equivalence, where we're measuring the same skill. I've seen some people bring in, they allow a little bit of time to examine. They have the parallel forms, but they don't give them the same day. They maybe give them a couple of hours later, maybe even a day later. And again, if you bring in the time component, you bring in a stability component, and then it's called a coefficient of stability and equivalence. Now, let me pat you guys on the back a little bit here and give you some motivation. Don't think you've got to get all this memorized. This is just kind of wetting the whistle. It's just trying to get you familiar with some of the dialogue, so, the things that we do in education research when it comes to either creating our own instrument, creating our own measure, or using one that's already in existence. So, guys, it's going to be this isn't a sprint. This is a marathon. It's going to be a slow process. Right now, our focus is just on how we establish reliability, how we measure reliability, and the different types of reliability that we encounter. Guys, down at the bottom, we say the alternate forms of test. As I said earlier, it's difficult. I think it's impossible to design two truly equivalent exams, so you violate that slightly. But everything else is the same. Same number of questions, same format. The look of your exam, everything else is identical, except the actual questions are different, but we want those things to be slightly different. And guys, in the testing and measurement world, slightly different is kind of the difference between being pregnant and a little bit pregnant. It doesn't work that way. You either are or you aren't. So these questions are seen, again, to be close, but they're just different questions. Oops. All right, guys, internal consistency, reliability. This is the third thing that we get into. And again, just as the name said, I think of the others as kind of an external consistency. Test, retest. That implies that we give the test 2 times, we look at the results. Internal consistency actually dives into the test itself and looks at the internal consistency of the items. Now, this is something where we'll get into something called factor analysis, and Well, we'll talk about that at the proper time. But guys, the goal here is, are all of the test items contained in the test measuring the same thing? So internal consistency reliability requires only a single administration, because there's not this external consistency going on like we had with the test retest. So guys, let's talk a little bit about the internal consistency reliability. One that you see a lot is called a split half reliability coefficient. It's really simple. It's certainly got some nuances that I'll talk about, but it's simple in terms of administration. You just take for example, 100-item test, you give it to a large group, and so there's one administration, an hour, 2 hours, 3 hours a day, 2 days later, whatever. You divide the responses into two halves. Some people will say, well, we'll take all the odd questions and put them in one group, all the even questions and put them in another group, and we'll calculate a correlation coefficient. I don't like that. I guess some other people say, well, let's just do it randomly. You choose 50 questions, I'll choose 50, and we'll look at the correlation. I really don't like that one either. I really like something that we're going to learn here in about 3 or 4 videos, something to do an item analysis. So look at the difficulty of the items and pair difficult items with a similar difficult item, and look at the correlation coefficient that way. But guys, that's something we're going to get into the nuts and bolts, the calculations, the formulas in later videos. But this one again is just try to get you familiar with things that we do in terms of establishing reliability. Guys, I will tell you this process is flawed, because this correlation coefficient will be an underestimate. And the reason it's an underestimate is, let's see, why is it an underestimate? Oh, it's an underestimate because of the sample size issue. If you take a 100-question test, and if you split it into 2 tests, that you do in a split half reliability coefficient, then you're creating 2 tests with 50 items. And as we'll find out later, there's some nuances, some inherent things that naturally inflate and deflate these reliability coefficients, and the number of questions is one of them. So naturally, the more questions you get, holding everything else constant, the reliability coefficients will be higher. It's kind of like this. If you think about hypothesis testing, you take the same standard deviation, same standard error, the same point estimate, the same value that you're testing. You increase the sample size, you decrease the standard error. So you're going to increase your test statistic, and your p-value is going to go down. So it's kind of the same phenomena. Guys, an approach at controlling for this underestimation is called the Spearman-Brown prophecy formula. Probably in video number 3, you're going to learn far more about the Spearman-Brown prophecy formula than you ever cared to know. But this, unfortunately, gives you a slight overestimate, because it makes the assumption that the 2 tests, the 2 halves, I should say, are perfectly representative of each other. And it turns out that usually isn't the case. I have to work on my PowerPoint skills here, guys. Staying in the realm of internal consistency reliability procedures, we get homogeneity measures. Beauty of it doesn't require splitting into 2 halves. And again, this is an internal consistency procedure. But it examines 2 types of error. First of all, it looks at the content sampling, and it looks at the heterogeneity of the domain. So it's a measurement that you see. It's not, in my opinion, it's not one of the most common internal consistency reliability procedures. Speaking of common, the Cooter-Richardson procedure, called the KR20, in my opinion, is the second most widely reported internal consistency reliability. And what it does is it examines the proportion of correct and incorrect responses to each of the items on the test and the variance of the total scores. This is applicable to tests that are dichotomously coded, and there are actually two versions of the KR20. One assumes that all test items are equally difficult, and the other assumes that the difficulty varies. This is really appropriate for a test with homogeneous content, such as if we gave a math test covering fractions. Now, guys, the one that I am most familiar with, and I think by far it's the one that's most widely reported just because of its generalizability, or I guess it just has more situations where it's appropriate to use it. It's called Cronbachs Alpha. So it has wider applications than the KR20. If you have a dichotom, it doesn't require dichotomously scored items, but if you do, it'll give you the same reliability as the KR20. So it's appropriate for Likert scales where we range things from 1 to 5 or 1 to 7. It's also appropriate for types of questions that vary in the assignment of points, like essay questions. So guys, this is probably the screen that means the most right now. And if we look at this, the number of test forms, we can either give 1 or 2. And then the number of administrations, we can give 1 or 2. So you can see there that anytime we give 2 tests, we get into equivalent forms. And those equivalent forms may be given at the same time, or they may be given after time elapsed. So anyway, notice that if you have 1 administration and you just have 1 test form, then your focus is on the internal consistency. If you have 2 administrations, then you're looking at a comparison of 2 tests. It could be a test retest, or it could be equivalent forms. But guys, this is important stuff when it comes to reporting and using measurements in education research. In fact, you just can't hardly get through without knowing something about this stuff, especially if you're going to publish. You can't get through it without knowing about this. All right, gang, the whole truth and nothing but the truth about reliability coefficients. I don't know where I came up with that. Number 1, length matters. As I said, the number of test questions has an impact on reliability. So the longer the test, the greater the reliability coefficient. Shorter the test, the less reliability. And again, that should be really no surprise. Because if you think about it, just like if, say, we're sampling from an infinite domain, and I call this a universe of items, the larger the sample size just should be more representative of the universe of items. So that's why we have more reliability. Second thing, group heterogeneity matters. The more heterogeneous the subjects, the greater the reliability. Homogeneous means not much variability. Heterogeneous means more variability in the subjects. So more spread in the group increases the reliability. It's kind of like this. What if I was trying to, I've got a group of, first graders up to 10th graders. So I have a very heterogeneous group of subjects, and I'm trying to put them in their appropriate math class. Well, you're going to see clusters of central tendencies. But if I'm trying to just take first graders, for example, and place them into the different mathematical content that they'll be studying, I've got a more heterogeneous, more homogeneous group, and that would just naturally create a lower reliability. Third thing, ability level of the group matters. A test that's too easy or too hard will result in lower reliability. Now think about that. Why do you think? Well, if a test is really, really easy, then there's going to be most people are going to get the questions right. So there's going to be very little variability in the test responses. If something's too hard, there's also going to be very little variability because people are going to, miss most of the questions. So, again, less variability in responses is naturally and inherently connected to a decrease in reliability. Guys, technique matters. You can give the same test retest, split half. They give higher estimates. Equivalent forms just naturally give lower estimates. The nature of the variable matters. Tests of variables that are easier to measure yield higher reliability estimates. I would think that assessing academic achievement is much easier to measure than say a construct called aptitude, or even a construct called personality. So something that's harder to measure, such as personality, is just naturally going to give you a lower reliability. And finally, guys, the objectivity of scoring matters. Inconsistency in scoring just introduces error, and error reduces reliability. All right, gang, let's take a test. Speaking of test theory, let's take a test. So, guys, teacher prepares all of these are going to be what type of reliability coefficient is appropriate. So, a teacher prepares 2 forms of a math achievement test, administers the 2 forms to a group of students on consecutive days, and correlates the students' scores from the 2 administrations. Well, guys, we're clearly getting into a situation where we have 2 forms. We're getting into a situation where it's given on consecutive days, so the time is varying. So, guys, we should see that that's alternate forms and a coefficient of equivalence. Number 2, a college professor administers a 40-item multiple choice test in educational psychology. The scoring office provides the professor a reliability index found by dividing the test into 2 forms and calculating the correlation between the students' scores on the 2. Guys, this is a very easy one, right? Please tell me it is. Split half. Number 3. Teacher questions the results of a verbal aptitude test administered to her English class. She decides to have the students take the same test on the following day. She then correlates the 2 sets of scores and finds a coefficient of 0.90. So think about it. We're doing the same test to her students. So I have no idea why that's doing that, but I need to work on my PowerPoint. Again, since it's over, work on my PowerPoint skills. Since it's over time, it has to be a coefficient of stability, which would be a test retest. I think this is the last one. Commercial test developed and administered to 2 forms of standardized reading tests to a representative sample of elementary school students in the fall, again in the spring. So we got a time component. We have 2 forms, equivalent forms, I'm assuming. So, gang, we would have alternate forms. So we have a coefficient of stability and equivalence. The equivalence comes from the administering of the 2 forms. And the stability comes from the fact that they were tested in the fall and the spring. Oh, wow, got one more. Cool. A teacher wanted a reliability estimate of an essay test in her history administered at the end of the semester. She used software to calculate the variance of all the scores for each item and then plug the variances across the items into a formula. Something you're going to learn how to do, right? So clearly what she's doing here is internal consistency. So she would use Cronbachs Alpha. And the reason is because the reason you wouldn't use the KR20, it's not dichotomously coded because she's has an essay test. And I guess essay test would be scored on some range. So, guys, what's acceptable reliability? As I say here, I'm often asked, what's an acceptable reliability coefficient? My answer is it depends. Actually, I was just asked this about a week ago by one of my doctoral students. Some things to think about, some thoughts. Compare your results to similar results. Let's say that you decide that you want to use a particular placement test, and you're required by your by the research manual of your university, hence Shawnee State University, to create reliability and validity measurements. Well, look at what's been done out there with placement tests and compare your reliability and validity. Well, reliability is what we're talking about now. Compare your reliability measurements with theirs, and really you expect something very comparable, and you actually kind of hope for it to be higher. Most importantly, consider the consequences. I think this is the most important. If an initial decision can be corrected, then I think modest reliability is acceptable. So if you're making a decision based on the reliability index, but it's something that can be corrected, I think the threshold's a little lower. But guys, when you get into high stakes decisions, where you get into maybe admission criteria, placement of children in special education classes or programs, placement and developmental math, which has been shown to be a high-stakes decision. You want the highest reliability, so your threshold there would be about 0.90 to 0.95. Well, gang, that's all I got. We're going to have a couple of these. Probably the first 4 videos are just going to be just getting familiar with the dialogue, the terminology, the vocabulary. So hopefully what you know now is you know a little bit more about reliability. What is it? What kinds of ways can we assess reliability? You know, external reliability, internal reliability. What kind of measurements do we have to address that? So, guys, it's not a matter of at the end of this, turning you into a walking encyclopedia on reliability and validity. The purpose is to let you know that this stuff exists, and when it comes time for you to examine reliability and validity of an instrument that you may use in your research, to just have this stuff on your radar where you can go out, and look it up again and see how it's addressed. So, guys, that's all I got. Take care.